Hi everyone, welcome to your section 5.4 notes. Today we're going to get into multiplying polynomials. So last class we added and subtracted. So now we're going to get into multiplying, and then after your quiz tomorrow we're going to get into dividing, the two different types of methods of division. So here we go. Multiplying, we have a cubic monomial times a quintic monomial. So everything is just multiplying straight across. So I'm going to write this all out just so you can see it. You don't have to do this every time. So this is kind of like doing -4 times a to the third times 3 times a to the fifth. And what your commutative property of multiplication allows you to do is rearrange these. So I could do a -4 times 3 times a to the third times a to the fifth. Right? Because each one is each individual part. So then multiply together. So -4 times 3 is -12. A to the third times a to the fifth is a to the eighth. So when I multiply those together, I get -12 a to the eighth. If I were doing this on my own, I would just automatically go to -4 times 3 is -12. A to the third, a to the fifth would go to a to the eighth. Right? So not a whole lot of work necessary. All right, so now let's up our game a little bit and do a monomial times a monomial with more variables involved. So we have 2m squared z to the fourth times 8m to the third z squared. So if we use the method that I just said, focus on your numbers first. 2 times 8 gets me 16. So that becomes 16. I have an m squared times an m to the third, so adding those exponents gets me m to the fifth. 2 plus 3 is 5. And then we have a z to the fourth and a z squared. Adding those exponents gets me z to the sixth power. Okay? All right, again, pause me at any point in time. I'm going to keep plugging away at doing these problems. So see if you can try this one on your own. Okay, did you get 72, k to the fourth, y to the fourth? Hopefully you did. Let's get rid of that. There we go. All right, next one. Now we're going to take a monomial and we're going to multiply it by a binomial. So we have -2x being multiplied to 8x to the third minus 9x squared. So distributing, here we get -2 times 8, which is -16. X to the first times x to the third, add your exponents, x to the fourth. -2 times -9 is positive 18. X times x squared is x to the third. My polynomial is written in standard form, so we're good to go. All right, hopefully that wasn't too crazy. See if you can do this one on your own. Did you get -8r squared plus 10r? Hopefully you did, and I don't think I need to go through that. All right, how about a binomial times a binomial? You remember your good old FOIL? I don't ever use the acronym FOIL. It's just double distribution. That's what FOIL is, right? So if you think about it as double distribution, cover up the second half, distribute, distribute. So that gets you 6x to the third plus 3x squared. And then bring back the second half. So ignoring this, distribute that, -8x squared minus 4x. Combine any like terms. We got multiple x squared, so combining those gets you -5x squared minus 4x. So that is your FOIL if you think about it. Because remember, FOIL is first, there's your 6x to the third, outer, which would be your 3x squared, inner, -8x squared, last, gets you your -4x, right? So that is your FOIL, just double distribution, right? Okay, very good. Try this one on your own. Did you get 6k squared minus 11km minus 10m squared? Hopefully you did. All right, let's keep on plugging away to get to bigger and better. Ooh, here we have a monomial times a binomial times a binomial. Ooh, this is starting to get me excited here. Now we're going to get into the hard stuff. Okay, so if this were me, I personally would eliminate the binomial times the binomial first. You could technically distribute your 2x squared here and then multiply that new binomial by x minus 3, but the binomial multiplication is probably a little bit more complex than a monomial multiplication, so do the binomial first. So here we get x squared minus 3x plus 1x minus 3, combined like terms, gets me x squared minus 2x minus 3. And hopefully at some point you should be able to just kind of multiply that in your head and get to the x squared minus 2x minus 3. Now let's bring down that monomial of 2x squared and distribute. So 2x to the 4th minus 4x to the 3rd minus 6x squared would be your final answer. Okay. All right, now here we have a trinomial times a binomial, and all we really can do here is just keep distributing straight through. So I'm going to start with my first term. 3m to the 3rd times 3m is 9m to the 4th. 3m to the 3rd times negative 5 would be negative 15m to the 3rd. Distribute here. Negative 2m squared to 3m would be negative 6m to the 3rd. Distribute your negative 2m squared to the negative 5, so positive 10m squared. Now we have one more set of distribution to do with that 4, so the 4 to the 3m gets me 12m, and then the 4 to the negative 5 gets you negative 20. So now we got to combine all our terms together. There's no other 4th degree, or m to the 4th, so that one's done. Negative 15 and a negative 6 combines to make negative 21 m to the 3rd. Looks like we only have 1m squared. Does that sound about accurate? Negative 10, yeah, I guess so. So plus 10m squared. And then we've got just the 12m. And then the minus 20. Done. Answer. Circle it. All right, so trinomial times a binomial. Just take it one section at a time. Distribute, distribute. Now distribute, distribute. And then do your last set of distribution with the 4. So distribute, distribute. Okay. All right, let's move on. Again, pause me at any point in time. I know I'm probably moving fast, but you can stop me from doing that. All right, now these simple special products, right? Here you have a difference of 2 squares. You should be able to, at this point in your math career, be able to just come up with these answers like that and not need to FOIL them. So if you guys remember, I'm going to work it all the way out so you can see it. When I go ahead and FOIL or double distribute, I get p squared minus 7p plus 7p minus 49. And what happens to our middles? They cancel. So you should be able to see that and know right away that my middle terms are going to cancel. I'm just going to be left with the first and the last. So p squared minus 49. So if I had x plus 1 times x minus 1, you should know that it should just go right to x squared minus 1. Or if I had 3x plus 4 times 3x minus 4, it would go straight to 9x squared minus 16. Or if I had 7x plus 1 times 7x minus 1, you should know that it goes right to 49x squared minus 1, right? That should be something that you can do really quickly. So see if you can do this one really quickly. That would get you to, I don't know why I paused so long, 36m squared minus 25, right? Yes, hopefully. All right. How about this one? What would that one go to? 4x squared minus 125. Maybe you didn't remember what 15 squared was, but that's 125. Good. All right, so that's something you should be able to do really quickly at this point in your math career. You should also be able to expand a binomial that's being squared very easily without having to write it out and then FOILing it or doing the double distribution. So let me show you the trick. So remember that when you have something squared, that's the same as m plus 7, right? So don't put this in your notes, just watch. That gets me m squared plus 7m. Then we get another 7m plus 49. And when I combine that middle term, I get 14m plus 49. Okay? So here is the trick. When you have a squared binomial. So if you have something like x plus y squared, go ahead and put this in your notes. That's going to be equivalent to x squared plus y squared, but then your middle term comes from taking 2 times your x and your y. Now this is the visualization that I use when I do it. I square the first, I square the last, and then I multiply all those 3 parts together. So my x times my y times the 2, which gets you that 2xy. You see how that works? So if we use that trick over here, square the first, that gets me m squared, square the last, that gets you the 49, and this is where students always forget the middle term. Multiply all those together. M times 7 is 7m. 7m times 2 is 14m. See how that works? Let's try another one before I make you do one on your own. So let's do something like 3x minus 1 squared. So squaring the first, 9x squared, square the last, negative 1 squared is positive 1. Now multiply all 3 of these together. 3x times negative 1 is negative 3x times 2 is negative 6x. So we get 9x squared minus 6x plus 1. I did it with, let's say, 2x plus 5. Square the first, 4x squared, square the last, 25. The middle, multiply it all through. 2x times 5 is 10x times 2 is 20x. Okay, so see if you can do this one on your own. Did you get 9m squared plus 24m plus 16? Hopefully you did. Okay, so now let's use these new thought processes on some more elaborate problems. This is where it gets really exciting, guys. This is where we're advancing our algebra. You're finally maybe getting some challenge problems pushed at you. So now think about this. Right now I have a difference of squares. I have my green plus, get a different color here, my red, and I have my green minus my red. So that's my difference of squares. So notice I have a plus in between. I don't know, I'm pointing at the screen like you can see it. I have a plus here and I have a minus here. So I have a difference between those two squares. And what happens when you have something like x plus y, x minus y? Remember, your middles cancel out and you're just left with x squared minus y squared. So technically my green is my x, right? And my red is my y. So if I use this thought process right here and square my green and then square my red highlighted part and then simplify, that should get me to my right answer. So let's go ahead and see what that looks like. So squaring the green part would be 3p minus 2 squared. And then it's always a minus. Squaring my red highlighted part would be 5q squared. So now simplify further. We just practiced doing this. So what does that go to? Squaring the first gets me 9p squared. Squaring the last gets me positive 4. Multiplying everything together, 3p times negative 2 is negative 6p times the 2 up here is going to be negative 12p. Okay, everybody's okay with that? If not, FOIL it out if you need to. Minus 5q squared would be 25q squared. And there would be your final answer. And you don't have to rearrange it when it's like this. Technically, that's not in standard form, but just leave it like that. You could also potentially do more work for yourself and just distribute everything. So you could take your 3p to your 3p. So just watch this. Don't write this because it's going to be a lot of work. 9p squared. You could take your 3p to your negative 2. So negative 6p. You could take your 3p to your negative 5q, which would be negative 15pq. Then I could take my negative 2 to everything. So negative 2 to 3p would be negative 6p. Negative 2 to negative 2, positive 4. Negative 2 to negative 5q is positive 10q. Then take your 5q.
Newton, please come to the main office.
Hold on.
Newton, please come to the main office.
Okay, so we could potentially keep going and do, sorry, I got an announcement that distracted me. The 5q, is that where I was at? 5q to the 3p would be 15pq, 5q to negative 2, so negative 10q, and then we get negative 25q squared. And then combine all those like terms. So 9p squared doesn't have anything to combine with. I have a negative 6p combining with a negative 6p. That's where that negative 12p would come from, right? There's your plus 4. And then what happens to your pq's? Here I have a negative 15pq and a positive 15pq. Those cancel. Here I have a 10q and a negative 10q. Those cancel, right? And then you're left with the minus 25q squared. So you could technically do it that way by distributing everything, but if you remember the rule, it makes it a lot simpler, right? Okay. So see if you can try this one on your own. Did you get x squared minus 2xy plus y squared minus z? Hopefully you did. All right, so now let's use our rule for expanding, right? So remember when we had x plus y squared, that was the same as x squared plus 2xy plus y squared. So here is your x, the red. Here is your y, the 1. So squaring the red, squaring 2z plus r squared, plus 2 times my red times my blue, plus my blue squared, which would be 1 squared. Separate that. So now let's multiply and square that. So squaring the first gets me 4z squared. Squaring the last, r squared. Multiplying everything together, 2z times r is 2zr times 2 is 4zr. Distributing through here gets me 4z plus 2r, and then 1 squared is 1. And then just leave it like that. Again, you could technically rewrite this twice. Oops, let me finish this. They're going to start talking. And then distribute everything. Oops, 1. And distribute everything through like we did in the last one, but it's going to be a lot more work. Okay, so hopefully you can try. Let's get out of here. The next one on your own. Did you get x squared plus 8xy plus 16y squared plus 2x plus 8y plus 1? Hopefully you did. All right, so now the last thing that we have to cover is what happens when we have an exponent that we have to expand to for the fourth. And here our trick is, if you guys remember our rules of exponents, x minus 5 to the fourth is the same as x minus 5 squared times x minus 5 squared, right? So then, where do we go from there? Well, this goes to x squared, middle x times negative 5 is negative 5, x times 2 is negative 10x, square the last, plus 25. Right? So that's just the same as this squared, because the second one will be the same thing. So now we can either try to use our rule there and multiply that through, or we can just redo it twice. So x squared minus 10x plus 25. And we can just distribute through 3 times. Technically what you could do is you could group it. Could do this as like your first, and then you could do this as your second. Square the first, multiply to get the middle, and then square the last. Or you can just multiply it 3 times and do your distribution. That's up to you. I'm going to do it 3 times, and I'll show you how both ways works. So x squared times x squared is x to the fourth. X squared times negative 10x is negative 10x to the third. X squared times negative 20 or positive 25 is plus 25x to the second. And then do the negative 10x to everything. So here we have negative 10x to the third. Negative 10 to negative 10 is positive 100x squared. Negative 10x to 25 is negative 250x. And then 25 to x squared, so plus 25x squared. Oops. 25 to negative 10x, so negative 250x. And then 625. And then start combining things. So x to the fourth doesn't have anything to combine with, so that's x to the fourth. X to the third looks like we're going to negative 20x to the third. And then we've got an x squared, 25 and 25 makes 50, plus 100, so 150 x squareds. My x's, 250, 250 gets me negative 500x. And then the 625 stands alone. Now, if you wanted to use the actual trick to do that, where I think about the green being my first term and the red being the second term, so if you square the first, so my first is x squared minus 10x, right? And then the middle term comes from 2 times your first, so x squared minus 10x, times the last, which in this case is 25, plus squaring the last, so 25 squared. So squaring this first binomial gets me x to the fourth for my first. That would be 100 x squared for the last. Your middle would be x squared minus, or x squared times negative 10x would be negative 10x to the third times 2, so negative 20x to the third. In the middle here, your 25 times your 2 is the same as 50, and then I'm going to distribute my 50 through. So 50x squared minus 500x plus 25 squared, which is 625. So see how that matches up with what we have down there by combining your x squareds. So x to the fourth minus 20x to the third plus 150x squared minus 500x plus 625. So I got there a lot faster. I don't know which way is the better way. So if you can remember that rule where you square the first, square the last, and then take 2 times x times y, so 2 times the first times the last in your middle, that might be quicker to do it. Or if you just want to plug through and distribute everything, go for it that way. There's more steps that way, so I guess there might be more room for error. But you have to also remember the shortcut way to get there quicker. Alrighty. Okay, see if you can try this one on your own. Much smaller numbers, so hopefully it's not as crazy. Did you get to x to the fourth plus 8x to the third plus 24x squared plus 32x plus 16? If you did not get that answer, let's go ahead and go through this one together. So I'm going to use the shortcut method where we have x plus 2 squared times x plus 2 squared. Squaring that first one gets you x squared plus 4x plus 4, which is just that squared. I'm going to make my first half be the x squared plus 4x, and then I'm going to make my second half, let's get a different color, slide up, blue, there we go, the blue, okay. So squaring the green gets you x squared plus 4x squared plus 2 times your green, so x squared plus 4x, times your blue, which is 4, plus your blue squared. Right, so we're doing green squared plus 2 times green times blue plus blue squared. That's ultimately what we're doing. So now squaring the green chunk gets me x to the fourth. X squared times 4x is 4x to the third times 2 is 8x to the third. Squaring the last gets you 16x squared. Okay, so there's that first set of expansion. For my middle chunk, 2 times 4 is 8. Distributing that 8 gets you 8x squared plus 32x. And then your last 16, 4 squared. Combining like terms gets you x to the fourth plus 8x to the third plus 24x squared plus 32x plus 16. Whew, that's an awesome problem. Okay, I think we're going to have a lot of practice with those. So let's go ahead and practice. See ya.